Today we are going to talk about tri-state buffer with active low control input. So this one is an active buffer, control buffer with active low control signal. Let's create one. So new project, paste, tri-state buffer with active low control signal. Okay. We don't have tri-state buffer with the active low control signal in CircuitVerse. So we are going to design one together. So use this one. This is the control buffer. You need input, call it input A, output, label as, is it connected? Yep. Label it as Y. You need another input. And label this input as control input, but use N to show that this is inverted or active low control input. To make control to be active low, since we don't have that specific buffer in here, we need to use an inverter. So go to gate, an inverter, connected here. Now let me minimize this. So this is a tri-state buffer with active low enable, CN. Let's start over. Truth table, CN. So if control, it is active low. So if it's 0, then the buffer is going to be enabled and input goes to the output. So if it's 0, Y equals A, which is 0. Y equals A, which is 1. In this case, when Cn is 1, then the value of A doesn't matter. It is going to be here. As we know, CircuitVerse doesn't have highs, it doesn't show high Z. It shows unknown, while it makes sense, but it's an open circuit, so it has to have some high Z or open circuit. So Cn, if it's 1, output is high Z because it is active low control. If it's 0, then the buffer is enabled. Whatever is in input, you are going to see in the output. In short way of showing this buffer, you can use this one as well. So let me use this border. Okay. For this one I need to remove this. So you have Y output, you have CN, this short form, control signal. If CN is 0, your output is going to be A. So Y equals to the input. If Cn is 1, then your control buffer is deactivated. So it is going to be Z. Got to change this one, active low control. Now here we have Cn, active low control signal. Basically these two should be changed, but let me delete this. So if control signal is X and Z, it doesn't matter what's the value of A. It doesn't matter what's the value of A, your output is going to be X or unknown. So if this is X or Z, your output is going to be unknown, no matter what's the value. It doesn't matter what's the value of A. But if Cn is 1 here, this column, if A is 0, so it is going to, if it's 1, it is deactivated. So your output is going to be high Z. If Cn is 1, no matter what's the value of A, you have high Z. If Cn is 0, then the buffer is enabled. In this case, if it's 0, if A is 0, output is going to be 0. If it's 1, output is going to be 1. If it's X, if you don't know what's the value of input, then your output is going to be unknown. And if it's open circuit, again, your value is going to be unknown. Since CircuitVerse doesn't have tri-state buffer active low, we need this. So we are going to make one. Tri-state buffer active low. For the title, let's put it here. Then width, so control signal, let's put top. And let's make this height a bit higher. Y here and A as input here. Text, and now height. This is going to be our tri-state buffer with active low control signal, and we can use it later if we need it. Save. That's all about control buffer with active low enable or active low control signal.